Hi student. రావట్లే. Hi students, good evening students. How are you, all of you? I hope so everybody is doing well. Very sorry for the late students, 2 minutes. Yeah, good morning, good evening. Good evening students. Okay students, so this is about your promo if you are a plus subscriber. So these are the benefits students. I hope so you already know. I hope so everybody. Okay students, so if you are a plus subscriber, so these are the benefits students. Kindly go through once. You can have a demo students in a special batches. You can attend all the teachers special classes. It's a free. So kindly observe. If you are comfortable, you can take a subscription as a monthly based, as a trial based students, monthly. First 1 month you can try. If you are happy, you can continue, of course. So if you want to go through once, you can have my referral code. Please use this referral code and you can get the 10% of the discount students. So please use this referral code. Now already currently batches are going on students. 2 batches are running and tomorrow 1 more batch is going to start for a Telugu batch, TS and AP EAMCET 2021. So we are going to complete within 4 months. All variety of tricks we are going to give students. So now we'll start the students the paper discussion over here that. So in this paper discussion students over here, the last YouTube section already I have discussed few problems, around 20 sums we have discussed. Now remaining 20 sums I am going to continue now students. See here students, dimensions of epsilon naught. First of all, what is epsilon naught students? Here epsilon naught is nothing but permittivity of free space. This is a permittivity of free space. So permittivity of free space in electrostatic part, if you see students, when 2 charges are separated distance 1 by 4 pi epsilon naught q square by r square we can say. Students, hi, good evening everybody. I forgot to say students, good evening everybody. Students, before giving some comments, please have some kind of sense. The sense you can have, you can give a message students. So electrostatic force, if you consider 1 by 4 pi epsilon naught q square by r square. See students, unit of force you know that, Newton. Here charge, current into time. Yes students, current into time, ampere seconds. The distance, meters. So 4 pi is no unit. So here the dimensions of epsilon students, generally for any chapter, please take care students, those who are preparing. Hi sir, are you able to see my messages? Yes Karan, I am able to see your messages. Okay na Karan? Hi Samrin, good evening. Samrin Shea, good evening. Ashwatthama, something he said I didn't understand. Okay students. See, dimensions are very important, students. For any entrance, if you consider either JEE or NEET or any entrance, so compulsory there is a possibility to ask one question of units and dimensions. You should not miss for this question marks. So take care, students. So you require to find epsilon naught. So 1 by 4 pi f q square by r square. So permittivity of free space 4 pi no unit, students. 1 by force m1 l1 t minus 2, and current, students, charge, students, current into time, and twice it is there. Since it is there twice over here, I need to take as a twice over here that I2 and then T2, students. I2 T2 by distance square L square. See here, students, if you go for mathematical steps over here that M1, if I bring numerator M minus 1, here L1 L2 is there, L minus 3, T minus 2 is there, students, M1 L1 T minus 2, and current square over here I square. So minus 2, if I take numerator T square, already T square is there, students, T power 4, and then current I square. So M minus 1, L minus 3, T4, I square. So you can represent I or A, you can say, students. So option 1 is the perfect answer. Yes, students, all of you, I hope so you are understood this. Okay, students, next question. We'll move on to the next question, students. If the angle of dip at two places are 30 degrees and 45 degrees respectively, so then the ratio of horizontal component of Earth's magnetic field at two places. See, students, horizontal component BH is equal to B cos theta if I represents. Then, so resultant magnetic field will be B if I say, students, BH1 upon BH2 is equal cos theta 1 upon cos theta 2. So you can substitute the values, and then theta 1 is 30 and theta 2 is 45. Then you'll get the option 1, students. Okay, students. See, generally resultant magnetic field will be B along this side. Here theta if I say. So B resultant magnetic field is B cos theta, and then B sin theta, we can say, students. So B cos theta over here horizontal component, and B sin theta, students, it is a vertical component, it is there. Next, students, Lenz's law is a consequence of Hi everybody. Lenz's law is a consequence of law of conservation of energy, students. Lenz's law is a consequence of conservation of energy. What is Lenz's law, first of all? So EMF caused or induced EMF opposes the cause produced. Induced EMF opposes the cause produced. It is a consequence of conservation of energy. Lenz's law gives the direction of EMF. Over here, direction of induced current, we can say, students. Yes, students. 3 capacitors of capacitance 2 microfarad, 3 microfarad and 5 microfarad are connected in series. A potential difference of 155 volt. See, students. 3 capacitors over here. Just a minute, students. Three capacitors are connected in series. 3 are connected to a potential of the battery. Over here 155 volts, I hope so. Two, 3 and then 5, students. 2, 3, 5 and 155 volts. 2, 3, 5, 155 volts. 2 microfarad, 3 microfarad and then 5 microfarad. So anybody remember, students? See, these two are effective capacitance. First find out, students, effective capacitance. So what is effective capacitance, students? 1 by 2 plus 1 by 3 plus 1 by 5. So then we'll get over here that 1 by C is equal So you can take LCM students over here. Then LCM is 30. Then you can simplify students, 15 plus 10 plus 6. So finally C effective is equal 30 by 31 microfarad students. So this is the effective capacitance. Then how much charge distributes? If I consider over here that Q is equal C effective into potential. So Q is equal C effective is how much students? 30 upon 35. And how much potential is there over here? Battery potential is that 155 is there. 5. Then Q is equal to how much students? 150 microcoulomb is there. Since over here 150 microcoulomb is passing over here, that 150 microcoulomb is the charge. And here capacitance students 2 microfarad. So what is the potential students? We can say V1 is equal to Q by C. So 150 upon 2. Is it clear students? Microcoulomb, microfarad. Okay students, micro gets cancelled. Finally we will get 75 volts will is the answer. Yes students, everybody got clear? So 75 voltage is the answer. And effective is 30 by 31 microfarad. In a series LCR circuit, the inductive reactance is twice the resistance and the capacitive reactance is 1/3 of the inductive reactance. Then power factor. Students over here, power factor if we consider cos phi is equal to R by Z is the power factor. And in LCR series, in LCR circuit, Z is equal to under root R square plus XL minus XC whole square, where XL is inductive reactance omega L, XC is students 1 upon omega C. Generally it's basically will write, but according to the given point of view, inductive reactance is twice the resistance. Inductive reactance is twice the resistance and capacitive reactance is 1/3 of inductive reactance, XL by 3 we can say. What is XL students? 2R by 3. So XC value you know, now XL value you know. So can I substitute over here students this value? So what I'll get now here? Z is equal to root of R square plus XL is 2R minus 2R by 3 whole square. So finally what I can say students? R square plus 6R minus 4R. Yes students, 6R minus 4R is how much? 6R minus 2R, 4R by 3 whole square we can say. So finally how much students? 25R square by 3 square means 5R by 3 we can say. This is the impedance Z value. So after getting Z value, can we substitute over here students this value over here that cos phi is equal to R by Z. So if I substitute over here R upon, so what is the value students? 5R by 3. So R gets cancelled, then cos phi is equal to 3 by 5. So we'll get over here that 0.6 is the answer. Option 3. Yes students? Parth got clear? Ishwar Rao got clear? Next. The deflection, it's a very nice question students. The deflection produced in a tangent galvanometer, the deflection produced in a tangent galvanometer whose coil has a resistance 9 ohm is 30 degrees. The potential difference across the coil is 4.5 volts students. 4.5 volts. The number of turns are given 10. Then the radius of the coil you are going to find students. So the radius of the coil if you want to find, first of all, how much current is passing? Applied voltage 4.5 upon 9. Yes students, we'll get over here that 0.5 amperes we will say. So basically what is the basic formula students? B is equal to BH tan theta according to tangent law. So what is B value students? Mu naught Ni by 2r is equal to BH tan theta, we can say. So theta value is given 30 degrees. And mu naught value, you know students, 4 pi into 10 to the power of minus 7. And number of turns students, 10. Current already we got 0.5 upon 2r is equal to BH is that 1 upon root 3. So 3.14 gets cancelled. So 2 1s are 2 2s are 2 into 0.5 students 1. So minus 5 minus 5 minus 2 is there, 1 gets cancelled. Finally what will get students? Root 3 into 10 to the power of minus 1 we are getting students. But the given problem, if you see now, if I multiply and then suppose you see students 10, if I multiply with a minus 1, if I increase, nothing change over here. So 10 root 3 into 10 to the power of minus 2. Option 2 is the excellent perfect answer. Yes students, got clear? Everybody students, please ask me if you did not get. I will explain anyhow if you not get. So whichever I have went to discuss during last class, those questions I am giving students. Mostly I didn't discuss, I am not remember students this one. Force and then displacement is given. Work done, product of force and displacement, we can say students. So 5 into 6, 34 into minus 5, minus 20. We will get students 10 joules, we can say. Option 1 is the answer. So this anyhow theoretical question only, we can say students. Over here that dq is equal, first law of thermodynamics says over here that dq is equal to du plus dw, we can say over here that. So dq is equal to du plus dw, first law of thermodynamics. Okay, so yeah, light from a source travels, out with a velocity c. If the source moves away from the observer, relative velocity of light with respect to observer. Students, the standard formula for this is that v is equal to w minus u upon 1 minus w upon c square. Yes students, then here is given that light from a source travels with a velocity c. So v is equal to c into u by 1 minus c into u by c square gets cancelled over here. Sorry, c minus u, of course. C minus u upon c minus u upon c gets, numerator is c, gets cancelled. Finally we will get the answer as c. Yes students, you can remember this is the formula for this. Suppose the question, if they give light moves away, travel with a speed c by 2, you can substitute the value w in place of w, c by 2, we can say. Whatever they given, you can say. Which of the following set of concurrent forces may be in equilibrium? Students, resultant expression is that root of a square plus b square plus 2ab cos theta, where theta is angle between a and b, students. So the resultant will be, depends on cos theta. So if cos theta value is plus 1, so r value is maximum, students, a plus b. If cos theta is equal to minus 1, then r value, students, a minus b. So always remember that it is having a variation from r maxima to r minima, a plus b to a minus b. So 5 plus 3, 8, 5 minus 3, 2. So this is cannot be possible. 5 plus 3, and this is also cannot be possible. 5 plus 3, 8, 5 minus 3, 2. So 6 Newton is in between. You can say over here that. Okay students, yeah, 3 plus 5, 8, 3 minus 5, 2. It is also not possible. Yes students, okay Pranav, okay Parth. Radiation intensity is given, students, striking a metal plate. Then the pressure on the plate. So pressure is equal, students, I by C, we can say, students. So what is the intensity given, students? 0.5. And then this value, students, light velocity, you know that 3 into 10 to the power of 8. Then if you simplify, you'll get the answer as 1, students. Okay. Okay students, any doubts please send me a message. I'm here to make you perfect. What is the phase difference between two particles 25 meters apart in a wave represented by the equation? See students, y is equal a sine, if I compare over here that omega t minus kx, standard equation. Omega is 2 pi students, k is equal 0.01 pi. So k is nothing but students 2 pi by lambda, we can say of course. 2 pi by lambda is equal 0.01 pi. So pi gets cancelled, then lambda is equal to how much students? 200 meters. Then what do you have to find students? Phase difference. Since you know that phase difference is equal to 2 pi by lambda into path difference. So what is the path difference is given students? 25. And lambda value students 200. 25 ones are 25 eights are. So 2 ones 2 fours. So finally you will get the answer as pi by 4 is the perfect answer. It is tough. No, it's not tough here. If you know the concept, definitely it is very easy. Okay. The weightless bag is filled with 5 kg of water and weighed in a water using a spring balance. Then the reading of spring balance is apparent weight remains 0. Why? Because students, amount of volume spelled equal to the volume of the bag. Since here inside the density and here density same students, then the weight and then beyond force both must be same, so that the resultant force is equal 0 we can say. Yes students. So gamma is equal to 1 plus 2 by f degrees of freedom. So from this students, gamma minus 1 is equal to 2 by f. So finally over here that, thank you very much, 2 by gamma minus 1. Yes, thank you Parth. Okay students, then find the centripetal force acting on a coin 0.1 kg placed 0.1 meter from the center. Then the omega value is given students. Straight away you can do f is equal to mr omega square. Mass is given students 0.1 kg and radius is given 0.1. What about omega students? 600 revolutions per minute. 2 pi by 60 we can say 10. So omega is equal to 20 pi. So you can multiply students 20 pi whole square we can say. So what we can write students? 0.01 into 400 pi square. 100 gets cancelled. 0.01 4 pi square is the perfect answer, option 1. Yes students, it is anyhow standard question students. Solar we have discussed I think so, but still we'll do students. Next 2 questions we'll see. If we not discuss, then we will come for that. So the speed of a uniform solid sphere after rolling down from rest without slipping along a fixed inclined plane of vertical height h. Yes students. So if you observe over here that the speed of uniform solid sphere rolling down from rest, solid sphere students over here. So it is initial velocity is 0 as soon as it reaches students. So the total potential energy will be converted as a kinetic energy we can say. So what you can say students, mgh is equal the total kinetic energy students. What I can mention over here that half I omega square plus half mv square. Is it clear students? The total kinetic energy, because it is rolling. So since it is rolling, we can mention students rotation plus translation. In case of rolling, rotation plus translation we can say students. So rolling, rotation plus translation. So what we get students? Finally half I omega square plus half mv square. So you can substitute over here students. In place of I, you can write over here that 2 by 5 mr square. Yes students, 2 by 5 mr square, and then here we can mention over here that half mv square we can say, students. Anything else, students? Got clear now? Then mathematical steps, students. Then you can get easily over here. So after this, students, when a rectangular coil is rotated in a uniform magnetic field about the axis passing through its center and perpendicular to the field, the EMF induced in the coil varies as. See here, when a rectangular coil is rotated in a uniform magnetic field. See, students, previous question can you solve, students? Actually, I didn't solve. mgh is equal to half into, what's the moment of inertia, students? 2 by 5 mr square and then v square by r square plus half mv square, students. R square gets cancelled, 2 gets cancelled. Then mgh is equal to what we can say, students? 1 by 5 mv square plus 1 by 2 mv square. Then if you simplify, students, v square value will get root of 10 gh by 7 we can say. Next, friends, when a rectangular coil is rotated in a uniform magnetic field about an axis passing through its center and perpendicular to the field, the EMF induced in the coil. See, students, induced flux is nothing but B bar dot A bar. So which is equal to BA cos theta. So the magnetic field lines passing in a given area is the flux. Then induced EMF is equal to what we can say, students? Negative rate of change of magnetic flux. So minus d by dt of flux is equal to BA cos theta. So what will get, students, over here? BA into d by dt of cos theta. Already minus is there, of course. Then induced EMF is equal to minus BA d by dt of cos theta, students. What we can say over here, that minus sin theta and then d theta by dt. D theta by dt is nothing but, students, omega we can say over here, that t is equal to minus into minus plus BA omega sin theta we can say over here. So finally, students, here theta is equal to omega t, rate of change of angular displacement is theta is equal to omega t. So if I substitute over here, so what can I mention, students, over here? BA omega sin omega t. It is the maximum. If I say peak value is equal to E naught sin omega t. So sin, we got an equation over here that E is equal to E naught sin omega t. So here sin it is represents, so sinusoidally, either sin or cos represents as a sinusoidally. Hi everybody, students, actually I was teaching continuously, I am unable to observe your messages. Hi sir, Tejendra, I am from Kishore Sir Army, thank you. Understand everything by you, thank you. Hi Ranjita, how are you? Students, please follow me. Even in plus class also, definitely I will provide you the best knowledge for you, students. Please follow my page and then I am ready to explain you whatever you require, students. Okay, students. See, students, last question I will give you hint, students. Stress developed inside a tooth cavity filled upper when hot tea temperature is given. So you require to find, students, for this, for here, that stress is nothing but volume stress is equal to applied force pressure by area, or strain if I say, students, change in volume by original volume. Here Young's modulus if I say, students, stress by strain. So finally stress is equal to what, students? Y times strain we can say over here. So then Young's modulus times strain is nothing but delta V by V. So can I write, students, gamma is equal to delta V by V into delta theta. So what is gamma, students? 3 alpha. You know that relation between gamma and then alpha is 3 alpha. So delta V by V is equal to 3 alpha delta theta. So finally if I substitute over here 3 alpha delta theta, so then the stress is equal to Y times 3 alpha delta theta we can say over here. So whatever here Young's modulus I have used, students, you can say over here that bulk modulus whatever is given 140 and 3 into alpha value is given, students, and rise in temperature, students, 57 to 3720. If you multiply and then if you simplify, we will get the option 1. Yes, student. Ranjita Reddy, I don't know. Actually, I didn't see. Okay, now definitely I will discuss. Okay, students. So I hope so. Everybody understood, students, today's section. So in the next session, I'm going to come in front of you. The next paper, students. So thank you one and all those who are present in my class. Thank you one and all those who are present in my class. Thanks a lot. Okay, students. Thank you very much. Bye, students.